Okay, Wildcats, today we're going to set a red lesson, radical functions. Warm up, solve each equation for x. Okay, number one. So the first step is we're going to add 1 to both sides. You have y plus 1 equals x squared. And then the last step is you're going to take the square root of both sides. Now remember, square root's plus or minus, so that's plus or minus the square root of y plus 1 equals x. Which can be rewritten as x equals plus or minus the square root of y plus 1. All right, let's take a look at number 2. Okay, first thing we need to do is multiply both sides by the common denominator, which is 4. So 4 times y is 4y. 4 times 1/4 is 4 divided by 4 x squared. Now, anything divided by itself is 1, so this becomes 1. So you have 4y equals x squared. Now, last step is you're going to take the square root of both sides. Square root cancels the squared. So you get x equals plus or minus the square root of 4y, which can be rewritten as x equals plus or minus square root of 4y. All right, let's take a look at number 3. All right. Now, in this case, we're dealing with cubes, so we're going to take the cube root of both sides. Now, the cube root cancels the cube, so you're left with the cube root of y equals x plus 3. Subtract 3 from both sides. You get the cube root of y minus 3 equals x, which can be rewritten as x equals the cube root of y minus 3. All right, go ahead and finish that up. All right, let's take a look at the next page. Getting started. The root of the matter. You know that the inverse of a power function defined by the set of all points x and y and x comma f of x is the set of all points y comma x or f of x comma x. Thus, to determine the equation of the inverse of a power function, you can transpose x and y in the equation and solve for y. All right, go ahead and look over the worked example. Number 1. Why must the symbol plus or minus be written in front of the radical to write the inverse of the function f of x equals x squared? The inverse of the function f of x equals x squared is not a function. For each value of x greater than 0, there is both a positive and negative value for y. 2. Notice that the inverse of the function f of x equals x squared is not written with the notation f to the negative 1 x. Explain why not. The inverse of the function is not a function. The inverse notation is used only when the inverse is a function. Let's take a look at the next page. Activity 2.1. The square root function. You can use the horizontal line test to recognize that the function f of x equals x squared is not an invertible function. Are there any conditions for which the function f of x equals x squared could pass the horizontal line test? Number 1, the table shows several coordinates of the function f of x equals x squared. A. Use the ordered pairs in the table and what you know about the inverse to graph the function and the inverse of the function y equals plus or minus square root of x. Explain your reasoning. All right, so let's go ahead and graph these points first. So negative 3, 9, negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4, 3, 9. All right, now let's go ahead and graph the inverse in yellow. Now for the inverse, we switch the points. So then this becomes 9, 4, 1, 0, 1, 4, 9. It becomes negative 3, negative 2, negative 1, 0, 1, 2, 3. All right, so let's go ahead and graph those points. So 9, 1, 2, 3. 4, negative 2. 1, negative 1. 0, 0. 1, 1. 4, 2. And 9, 3. All right, go ahead and finish up the graphs. All right. B. What point or points do the two graphs have in common y? The graphs both include the point 0, 0 and 1, 1 because they are inverses. The graphs will share any points that have the same x and y coordinate. Two, describe the key characteristics of each graph. Function f of x equals x squared. The domain is negative infinity to positive infinity. The range is 0 to infinity. The x-intercept is 0, 0. The y-intercept is 0, 0. For the inverse of x equals y equals plus or minus square root of x, the domain is bracket 0 to infinity. The range is negative infinity to positive infinity. The x-intercept is 0, 0. The y-intercept is 0, 0. Notice that for the inverse, the domain and range switched. Okay. All right, let's take a look at the next page. All right, go ahead and mark this page out. All right, number 4. Graph the square root function f inverse of x equals square root of x by restricting the domain f of x equals x squared to only positive values for x. Okay, so let's go ahead and graph those points. So 0, 0, 1, 1, 2, 4, 3, 9. Okay. Let's go and do the inverse in yellow. Now remember the inverse, we switch the values. So then this becomes 0, 1, 4, 9. And this becomes 0, 1, 2, 3. Okay, so let's go ahead and graph those points. 0, 0, 1, 1, 4, 2, 9, 3. All right, go ahead and finish up the graphs. Number 5, describe the key characteristics of each function. Function f of x equals x squared for x greater than or equal to 0. The domain is bracket 0 to infinity. Range is bracket 0 to infinity. X-intercept is 0, 0. Y-intercept is 0, 0. For the inverse function, f inverse of x equals square root of x, the domain is bracket 0 to infinity, the range is bracket 0 to infinity. The x-intercepts are 0, 0, and the y-intercept is 0, 0. All right, let's take a look at number 6. Does the inverse function f inverse of x equals square root of x have an asymptote? Explain the reasoning. No. As x increases, the positive square root of x increases towards positive infinity. 7. Make a conjecture about the relationship between the domain and range of a quadratic function and its inverse. The domain of a quadratic function is the range of its inverse, and the range of a quadratic function is the domain of its inverse. All right, go ahead and finish it up. All right, let's take a look at the next page. Activity 2.2, domain restrictions. Let's look at more quadratic functions to explore domain restrictions and the relationship between the domain and range of a quadratic function and its inverse. Number 1, consider the function g of x equals x squared minus 4 show on a coordinate plane. A. How is g of x transformed from the basic quadratic function f of x equals x squared? The function g of x is translated 4 units down from the function f of x. B. Write the equation for the inverse of g of x and sketch its graph. Okay, so to find the inverse, first step is to switch x and y. So x equals y squared minus 4. Okay, now we're going to resolve for y. So we're going to add 4 to both sides. We get x plus 4 equals y squared. Run out of room, so let's come over here. Now, the next step is going to take the square root of both sides. Remember, square roots plus or minus. The square root cancels this, right? So then you're left with plus or minus the square root of x plus 4 equals y. All right. So let's go ahead and graph that in Desmos. Now it's plus or minus square root, so we're going to need to do of x plus 4 and negative square root of x plus 4. All right, so our points, we can use negative 4, 0. Oh. And that should be enough to get our graph. Let's see if there's another point that we can use that's very good. Nope. So let's just use this point, and this point. Oh, I'm sorry. We do have one point. We use negative 3 and 5, 3. All right. All right, go ahead and finish it up. All right, C. Is the inverse of g of x a function? The inverse of g of x is not a function because it does not pass the vertical line test. D. How is the inverse of g of x transformed from the basic square root rotation y equals plus or minus square root of x? The inverse relation y equals plus or minus square root of x plus 4 is transformed 4 units to the left from the basic square root function y equals plus or minus square root of x. All right, let's take a look at the next page. E. List the domain and range of g of x and the inverse of g of x. Function g of x equals x squared minus 4. The domain is negative infinity to positive infinity. Range is negative 4, bracket negative 4 to infinity. And the inverse g of x equals y plus or minus square root of x plus 4. The domain is bracket negative 4 to infinity. And range is negative infinity to positive infinity. Notice for the inverse, the domain and range switched. F. What conclusion can you make about the relationship between the domain and range of a quadratic function and its inverse when the domain is not restricted? The domain of a quadratic function is the range of its inverse, and the range of a quadratic function is the domain of its inverse. In this case, the inverse is not a function. G. How can you restrict the domain of g of x so that its inverse is also a function? I can restrict the domain of g of x to x greater than or equal to 0. Then the inverse of g of x would be a function. H. List the domain and range for both the quadratic function with the domain restrictions and the inverse function. The function g of x equals x squared minus 4. When the domain is restricted to x greater than or equal to 0, the domain is bracket 0 to infinity, and the range is bracket negative 4 to infinity. When the inverse of g of x equals g inverse of x equals plus or minus x plus 4, with the domain is restricted to greater than 0, then it would just be the square root without the minus. The domain would be negative 4 to infinity, bracket negative 4 to infinity, and the range would be bracket 0 to infinity. Notice again, when the inverse, the domain and range switch. Okay, I. What conclusion can you make about the relationship between the domain and range of a quadratic function and its inverse when the domain is restricted? The domain of a quadratic function is the range of its inverse, and the range of a quadratic function is the domain of its inverse. In this case, the inverse is a function. Let's take a look at the next page. 2. Consider the function h of x equals parentheses x minus 4 squared shown in the coordinate plane. How is h of x transformed from the basic quadratic function f of x equals x squared? The function h of x is translated 4 units to the right from the basic function f of x. B. Write the equation for the inverse of h of x and sketch its graph. Okay, so first step, we switch x and y. So x equals y minus 4 squared. Next step is we take the square root of both sides. Remember, square root is plus or minus. Square root cancels the squared. Left with plus or minus the square root of x equals y minus 4. We're going to add 4 to both sides. So we have 4 plus or minus the square root of x equals y, which we can rewrite as y equals 4 plus or minus the square root of x. All right, let's go ahead and graph that. So 4 plus of x and 4 minus of x. Let's see, we have that's a good point. 1, 5 is a good point. So let's do this one at a time. 0, 4. 1, 5. 1, 3. 'We're getting close. Oh, that doesn't look good. All right, so it looks like these 3 points are the best points we can get, which is enough to get our curve. All right, go ahead and finish up the graph. All right, C, is the inverse of h of x a function? The inverse is not a function. The graph of the relation y equals plus or minus square root of x plus 4 does not pass the vertical line test. D, how is the inverse of h of x transformed from basic square root function y equals plus or minus square root of x? The inverse relation y equals plus or minus square root of x plus 4 is transformed 4 units up from the basic square root relation y equals plus or minus square root of x. E, list the domain and range of h of x and the inverse of h of x. The function h of x equals parentheses x minus 4 squared. The domain is negative infinity to positive infinity. Range is bracket 0 to infinity. The inverse of h of x, y equals plus or minus square root of x plus 4. The domain is bracket 0 to infinity, and the range is negative infinity to positive infinity. Notice again, with the inverse, the domain and range switch. F. What conclusion can you make about the relationship between the domain and range of a quadratic function and its inverse when the domain is not restricted? The domain of a quadratic function is the range of its inverse, and the range of a quadratic function is the domain of its inverse. In this case, the inverse is not a function. G. How can you restrict the domain of h of x so that its inverse is also a function? I can restrict the domain of h of x to x greater than or equal to 4. Then the inverse of h of x would be a function. Let's take a look at the next page. B. List the domain and range for both the quadratic function when the domain restrictions and the inverse function. When f of x equals h of x equals parentheses x minus 4 squared, and the inverse of h of x equals h inverse of x is square root of x plus 4. When the domain is restricted to x greater than or equal to 4, the domain is bracket 4 to infinity, and the range is bracket 0 to infinity for the function. And for the inverse, the domain is bracket 0 to infinity, and the range is bracket 4 to infinity. Again, for the inverse, notice the domain and range switched. I. What conclusion can you make about the relationship between the domain and range of a quadratic function and its inverse when the domain is restricted? The domain of a quadratic function is the range of its inverse, and the range of a quadratic function is the domain of its inverse. In this case, the inverse is a function. 3. When the domain of a quadratic function is restricted to create an inverse function, what is the lower bound of the domain? Explain the reasoning. The lower bound of the domain is the x-coordinate of the vertex of the quadratic function. The lower bound changes when the basic quadratic function is translated. If the function is shifted left or right, the lower bound of the domain increases or decreases. 4. Complete the table to describe the effects of each transformation on the inverse of the quadratic function. The transformation of quadratic function f of x, when it's translated up d units, it's translated to right d units. When it's translated down d units, it's translated left d units. When it's translated right c units, it's translated up c units. And when it's translated left c units, it's translated down c units for the inverse function f inverse of x. The student works 5a and 5b. Let's take a look at the next page. Activity 2.3, the cube root function. The cube root function is the inverse of the power function f of x equals x cubed and can be written as f inverse of x equals the cube root of x. The table shows coordinates of the function c of x equals x cubed. A. Use these points to graph the function and the inverse of the function, c inverse of x. All right, so let's go ahead and graph the points first. So negative 2, negative 8, negative 1, 0, 0, 1, 1, 2, 8. All right, and let's go ahead and graph the inverse in yellow. And remember, when it's inverse, the point switch. So this becomes negative 8, negative 1, 0, 1, 8. This becomes negative 2, negative 1, 0, 1, 2. All right, so negative 8, negative 2, negative 1, 0, 0, 1, 1, and 8, 2. All right, go ahead and finish up the graph. B. Explain how you determined the coordinates of the points on the inverse of the function. I transposed x and c of x in the original function to determine the coordinates for the points on the inverse of the function. C. What point or points do the two graphs have in common y? The graphs both include the points negative 1, 0, 0, and 1, 1. Because they are inverses, the graphs will share any points that have the same x and y coordinates. Let's take a look at the next page. Two, why is the symbol plus or minus not written in front of the radical to write the inverse of the function c of x equals x cubed? The inverse of the function c of x equals x cubed is a function. For each value of x, there is only one and only one value of y. 3. Why do you not need to restrict the domain of the function c of x equals x cubed to write the inverse with the notation c inverse of x? The inverse of the function c of x equals x cubed is a function, so c of x is invertible. When a function is invertible, I can use the inverse rotation to write the inverse. 4. Describe the key characteristics of each function. Function c of x equals x cubed. The domain is negative infinity to positive infinity. Range is negative infinity to positive infinity. X-intercept is 0, 0, and y-intercept is 0, 0. The inverse function c inverse of x equals the cube root of x. The domain is negative infinity to positive infinity. Range is negative infinity to positive infinity. X-intercept is 0, 0, and y-intercept is 0, 0. 5. Does the inverse function c inverse of x equals the cube root of x have an asymptote? Explain your reasoning. No. As x increases, the cube root of x increases towards positive infinity. As x decreases, the cube root of x decreases towards negative infinity. All right, go ahead and finish up your notes. And have a wonderful Wildcat day.